All right. So hopefully you will get a bit out of this. The idea is to give you some underground or below the visible layer of what happens in the digital world and give you a bit of protective strategies to make you not one of the people who's going to get hacked. So from this course, we usually get 4 reactions. One is it's fascinating. I need to learn more. Where do I find it? All of that sort of stuff. Second one is, oh yeah, that's interesting stuff, but I'm not going to go out of my way to learn anything. Whatever you teach me is the only thing I'm going to learn. Doesn't worry me. The other one is, this is absolute rubbish. It has nothing to do with my job. You'd be surprised how much the digital world is impacting everything. So yes, it has something to do with your job. But again, if you're in a situation to learn this stuff, great. And the other one is, who cares? And that really is how it's perceived across the board. Now, the problem with the whole thing is we're also playing with people who are in IT, know a bit about security, have knowledge about the system, all the way down to people who have literally come off the farms. They haven't been exposed to high-end IT at all, and they are just quite happily using their laptops to do whatever they need to do. I try not to preach. Sometimes I do get on my soapbox, but most of the time I try not to. So let's have a look at what we're talking about when it comes to cybersecurity. So we've got this preconceived ideas about bad guys. We used to think that they were not very good, they were slovenly, they lived on Coke and pizza, had major problems with conversing with people, and they were literally a subspecies, let's call them that. In 2001, we had the introduction of Swordfish, which gave us a different outlook on what hackers were like. The hacker in Swordfish was outgoing, they were easy to communicate, could talk to anybody, didn't have an attitude, all of that sort of stuff. In 2018, we saw the introduction of a thing called Mr. Robot. Now, Mr. Robot, if you really want to see how a hacker works in today's world, have a look at Series 1, Episode 1, the first 10 minutes. They have the capability of actually being likable, is probably the best way of doing it. They have a likable attitude. They have the skills in the digital world, but they also have skills in getting information. They are what we used to call in the late 18th century and 19th century the snake oil sellers. Okay, they are very good at what they do. The problem is, one of the biggest problems we've got is a thing called a collective. Collectives have now come full circle. They used to be groups of people who were interested in a very specific thing. Anonymous has morphed into this collective that is literally has a shopping board of where you want to get involved. Very hard to get to. It's in the dark web, but it gives us an indication of exactly what is happening. But it also gives the bad guys and the nation states additional capabilities. The problem with anonymous and problem across the board with digital problems is the simple fact that the bad guys from nation states are going into these collectives, they're learning skills, they're learning capabilities, they're writing applications, they're writing all the things they need. They then bring them back to the nation states to increase the capability of those nation states hacking environments. These then teach their own people, and then they start feeding other people back through these systems. So as you can understand, they are building up their skill level at the expense of us, because Anonymous or shadow brokers or any of the others are targeting us in specific ways. So when it comes to what we're talking about, the digital world literally is anything that has some type of computer capability. So that's mobile phones, and most of us think that mobile phones are mobile phones. Well, they're miniature computers, tablets, Internet of Things, artificial intelligence, laptops, computers, smart devices, drones, 3D printers, you name it. Anything that's connected to the internet has a brain, is something that's in the digital world. The only way to protect yourself from being hacked is to actually understand what these systems do. And the only way to get you to understand what these systems do is we need to have some sort of focus on what they are capable of having achieved on them. So let's look at mobile phones. Easiest thing to talk about, we all have one. If you think about not only the operating system on the phone, but also the applications you got on the phone, what information is it collecting about you and how many people have access to that information? You probably don't think that's important. It is when you start pointing it out. Fair enough, account details, bank account details, credit card numbers and tax file numbers, probably not in your range, but you've got an app on your phone that allows you to play around with your bank. You have an app on your phone that allows you to pay bills, whether that's through your credit card or your bank account. You have access to your contacts. You have access to passwords for these systems that you put in there. You have access to text messages that people have sent you. You have access to the contact details of all your contacts. We also have access to things called near-field communication. So not only are we collecting information that is coming into machines, but we have the capability of tracking information that's leaving them. GPS histories, for instance, GPS locations. All of this information is readily available if you know how to get into a phone. In addition to that, the applications that we're putting on the phone can create us problems, especially in the areas of privacy and capability. So when it comes to what they are capable of doing, think about this. Fitbit has been around for a couple of years now, about 5 years. They have increased their capability, they could increase their understanding, their devices are now smaller, sleeker, more fashionable, okay? They also send out significant information from your device to their central location. Now, to us, the aggregation of that information is probably not that important. It's, I'm a drop in an ocean of a couple of million people. But if you start looking at what they actually generate, then you've got a few problems that come to notice. This is what is called the Strava heat map, and it shows all of the people who use the Fitbit, and the information that it gathers goes onto this map to show where people are and what they're doing and how much they're using it. This was hacked out of the system with all the data that goes into making it in 2018. Out of the information that was actually used, suddenly we had a realization that the information that we are seeing wasn't necessarily good for what is actually going on, because this information displayed two top secret bases that were based in Afghanistan. And because of what was happening, Marines wearing Fitbits were walking around the perimeters or running around the perimeters to keep fit, okay, were then highlighting where these locations were. That is the problem with that is one of the problems we have with anything to do with the digital world. That information cataloging that has the capability of causing us major problems. So let's talk about other things. Anonymous is a collective, shadow brokers is a collective. Shadow brokers are a collective of Russian users, and that is the significant part. You have to be able to speak Russian to get into shadow brokers. It is also backed by the GRU out of Russia. So as you can understand, most of the things they are doing is based on Russian attacking everybody else. In 2016, shadow brokers targeted, Shadow brokers targeted a laptop that was owned by the NSA. That laptop had 10.9 gig of data on it that was very, very vital to, it was old data, okay? So that was the justification for not getting your ass fired, but that old data contained a large number of zero-day exploits for a number of operating systems, including Microsoft, Apple, Android, Linux, you name it, there were zero-day exploits there. Shadow brokers then turned that information into what became known as the Eternal Blue hack, and that then sprang into things that became a bigger problem, which was, I forgot what its name. Eternal Blue, gone blank. No, lost it. Anyway, this attack became something that was used against the NHS in England. It was used against one of the biggest shipping companies in the world. Became part of the portrayer and non-portrayer attacks that happened 6 months after it. And it did show how big a problem just this information was. Microsoft, Apple, and Linux actually got very, very upset about it, because one of the justifications, or one of the strategies that they use, is if you find out a zero-day exploit, you are supposed to tell the organization and they will fix the problem. Unbeknownst to them, the problem actually had been fixed, but nobody had actually applied it. And that was also part of the problem. In 2020, as this wonderful year goes ahead, January 2020, the Marriott Hotel was hacked, and they were in the process of acquiring another hotel chain. And that information that was then used to play around with the stock market and cause a few problems. Twitter, 2020 in July, was an insider who decided to hack into a large number of very, very prominent people who used Twitter, send out a tweet from their accounts saying, if you send me 1 Bitcoin, I will send you 2 back. And as you can understand, there was a huge problem with that. Life Labs, beginning of this year as well, showed how big a problem just medical data can be, because not only was the medical data stolen, but it was released on the internet. One of the insurance companies for the Canadian industries found this information and then started comparing the information that was stolen and the medical problems that were displayed in this information against their insurance's database, and they started dropping people's insurance because they had a predetermined exposure to some of the problems that may be coming around. Once this was discovered, then there was a huge lawsuit against the insurance companies in that respect. Facebook, one of the other things about insiders is some people forget to do things. And we have a huge problem with a thing called shadow IT, which means is anybody who can think about using something. So I go out there, get software as a service, I run up a server, I put all live data on a system, I play around with it, find out whether it's going to work out that it doesn't. Most people will then just leave the information there. We've probably done it ourselves, you know, Dropbox, any of those type of environments, OneDrive, for instance. Okay, we're not using it anymore. You never access it very often. That type of stuff is still out there. The best thing you can do is delete it, get rid of it, not worry about it. Ransomware in the last 12 months has shown that it is a very, very financial driven process, because they've made a squillion out of it, because $11.5 million, and that is known losses. Okay, some people are not reporting it, so they can't track all this stuff as well. But it doesn't end there. We've got critical infrastructure, and that's something that we are constantly seeing in today's world. We have this reliance on everything digital, so power plants, sewage, water. How about traffic lights? You can drive up to traffic lights in Canberra, and you can plug a laptop into that and have access to a large number of traffic lights around that area. These are problems you've got to keep thinking about. Global positioning satellites. Can they be hacked? Yeah. Have they been hacked? Yeah. Okay, these are the type of things that we need to start looking at when it comes to what the implications of digital has on us. Now, in 2019, everybody will have heard of Stuxnet from 2008. Stuxnet was a piece of software that was written by the NSA and Mossad, according to sources. They've never actually admitted it, but it was designed to go into the Iranian nuclear power plants and crash the oh God, I'm having a bad day this afternoon. Crash the centrifuges. So the centrifuges that are spinning up the uranium, they literally melted down because, according to the panel, nothing was going on, but they were screaming in the background. We thought that was probably the last of the problems until 2019, January 2019, we came across a thing called Triton. Now, it was actually discovered by FireEye. It showed the capability of actually having the capability of causing more problems than we knew how to fix. Now, the problem with Triton was it targeted safety systems, as in making sure that if a gas got out into a refinery, or we had a leak in a refinery, it literally started shutting down the refinery. Well, Triton actually got into these safety systems and disabled this monitoring capability and allowed anything to happen inside a refinery. It was discovered by FireEye. They came across it accidentally because somewhere along the line it triggered early. It happened on a Friday night, and the people in the refinery started panicking. They called in FireEye. They came in and had a look, and they literally almost had heart attacks about the capabilities of what the system could do. Now, this is one of the newest problems we've got. And as I said, it's only been around for 2 years, but it has made people very, very aware of what impact these systems can have on people themselves. We've also got access to drones, and drones don't necessarily have to be the huge ones that we talk about in defense, where they slap on a couple of rockets and blow things up. If I can go and buy a $1,000 drone that can carry a grenade, it makes it a very, very effective way of killing people. Artificial intelligence, machine learning, there's things that are now coming through. Machine learning uses high-grade algorithms, and most of them, and both in artificial intelligence and machine learning, they are unique to the organization that's actually using that. And we have no way of knowing what information is being used and how that information is used inside the algorithm. So that again creates other problems as well. 3D printing, great stuff. Used to be a toy, okay? But now, Kenya last year, 3D printing houses for their underprivileged population. We've seen it printing kidneys so that people can have a transplant without having to worry about transplant. All of these sort of things are now happening quite happily. The biggest problem we've got is this wonderful thing called Internet of Things. Now, Internet of Things is literally a device that is connected to the internet that does a specific job or role. So the high-end stuff is things like Google Home, Nest thermometers, but we're also seeing vacuum cleaners and TVs and fridges and everything else. The problem with all of them is most of them are built with very, very limited access to resources. Now, what I mean by that is they've got minimum processing power, they've got minimum RAM, they've got minimum storage. So that makes them very, very hackable because they have no security. There was a hack that happened 3 years ago called Mirai, which targeted Internet of Things devices that had a username of admin and a password of blank. Okay, these are the things that we have problems with. The processing power doesn't allow encryption, doesn't allow security components to be wrapped around it as well. So we're now getting products. The only thing that drives Internet of Things is first to market. If I get my tool out there, everybody's happy. So when it comes to a hack, now there are 3 URLs on the labs. The first one was right at the beginning, and it's all about drones and artificial intelligence. The second one is this one, which is all about taking a cyber attack and putting it in the real world and show you exactly what happens. It's done by an insurance company, does show you some very, very significant things about what you hear on the internet and what it actually translates into when you're actually looking at a real life situation. So between an online store and an offline store, for instance. And the third one is actually when we get to it, all about how the progression of an attack actually happens. So let's look at the bad guys. The bad guys, we've had bad guys around for years, like centuries, millions of years, thousands of years. So in the old days, 10,000 years ago, you had something that I wanted, I came along and took it off you, or I tried to, and you stopped me from taking it. Great stuff, not a problem. So it was one-on-one, family against family, or tribe against tribe, okay? It was a known thing. Okay, they had something that you wanted, whether it was land or animals or whatever, I'm going to go along and take it. And my job is to stop you from doing it. So that sort of crime has always been there. In the late 14th, 12th century onwards, we had the introduction of banks, we had the introduction of stagecoaches, railways, moving money around, collecting money and using it for the benefit of a town, for instance. So the moment a bank goes in, the first thing that most people think of is, how the hell do I rob that? So we've now got a number of people, a gang. Think of Jesse James or Ronald Biggs and his gang. I have a group of 10 people who are now going to steal from a couple of thousand. So we've got this progression. There's a visible progression. When you get to Ronnie Biggs, for instance, he stole, there were 5 of them, and they stole from pretty close to 1 million people. Big deal in those days. 2014, we saw a hack on the target system in America that literally stole, 22 people stole from 34 million people. Okay, now that is escalation that we've never seen before. In addition to that, it does show that the digital world makes it very, very easy to be able to do that, because everything's connected, everything is invisible, and allows me to fiddle around and do whatever I like. And the chances of getting caught, and the target people, only one of them has been caught, has shown that there's a lot of things that we need to think about. So when you think about bad guys, one of the things we don't think about is the bad guys running it as a business. Okay, so there's a huge attitude when it comes to what the bad guys are doing and why they are doing it. So the problem with the bad guys is there's usually competition between rival gangs, and the rival gangs, they are making millions and millions and millions of dollars, okay, out of our stupidity is probably the best way of putting it. But not only do we have competition, but we also have collaboration. Okay, now an organization may not have the capability of doing X, and it doesn't matter what X is, whether it's writing code or picking money up from a bank or doing anything along those lines. Because they haven't got that capability, it's not going to stop them. So what they do is they go out to the dark web and they say to people, or they know people, and they say, well, we want someone to do X, and we will give you 10% of the proceedings as we do X. So what happens is I can get web hosting, I can get botnets, I can get zombie networks, I can get malware and exploitation kits designed, and all of this now becomes part of my attack against someone. It doesn't matter who that is. It could be a random attack, it could be a targeted attack. Either way, it is now something that we have to worry about. But when you think about it, there's other things that these businesses do. Operations, they make sure that the operation is working properly. Someone's got a project manager hack, haven't they? They've got to make sure the web hosting is in place, the botnets are in place, the malware has been written, how we're sending it out, we're going to do the reconnaissance, we're going to scrape the dark web, we're going to do all of this. So the operations side of it is very, very important. Next part of it is automation. I'll go a bit more into this in a second, but automation literally means I can press a button and it will do something specific against my target audience. Okay, that's great if I'm a bad guy, not so good if I'm a target audience. I have research and development. Well, it's no use me developing a malware kit that in 2 months' time is going to be absolutely useless because they've patched all the vulnerabilities that thing's targets. So I need to have the research and development in such a way that I can keep ahead of, by 2 months, of what is actually happening in the big bad world of the internet. There's marketing, and there's a very good video on YouTube about someone who is selling a DDoS service. Okay, and I thought it was tongue in cheek, but it's not actually. It's a real marketing thing. But that shows also why they are quite happy. They're quite happy doing this stuff out there. The second one is sales. So we have sales that consist of 2 for 1 or 10% off, that type of stuff. And then, of course, they have support. And the support for these organizations is quite incredible because it goes back to the automation stuff. The automation stuff, if I want to have an attack, it's nice to have a smoke screen. So if I give my exploitation kit to a couple of thousand young kiddies, okay, they use that exploitation kit and they blow it out and send it off to a couple of million people on the internet. They need some support. Okay, this is not working. I'm not making any money out of this. Okay, what have you done? How have you done it? all of that sort of stuff comes back to them and they can actually do something about it. Now, automation is something that we're now seeing very, very complexly done. Complexly done on their side, but it's really easy on the people who are using it because all they do is fill in a couple of details and press a button. So we now have software as a service or attacks as a service, and it's all done for the hacker for him, okay? Black Shades is one environment that comes to mind. It costs you $2,500. You get all of those things that we just discussed. And if you have a problem, they actually have remote access. They will remote into your server and fiddle around and make it work for you. Great stuff. But it also shows we now got cybercrime as a service. Okay, click of a mouse, you can hack someone. Great stuff, not a problem. So you're probably thinking, why me? Okay, why am I a target? Why am I a target of the bad guys, and why would they want to come after me? Most of us think that she'll be right, I don't have anything worth stealing, I'm not a big person, I won't have access to the things they're after. To them, $10 is $10, okay? And if they can get $10 off everybody in this class, I've just made $70, $60. But that shows you, sorry, $20. I've just made a rather large killing out of that. And that's also very noticeable when it comes to this type of thing as well. So what have you got that they will want? Well, the first thing is you have access to money. You get paid, okay, which is something that they don't. So you get paid, you put the money in the bank, you have access to that money, whether you want to go to an ATM and draw it out or you want to spend it over the internet, that is irrelevant to them. You have access to something like money. The second thing is you have access to intellectual property. Now, there is a chain of thought in the cyber security area. There are two different types of hackers, European and Chinese. European money always comes down to money, okay? Chinese, on the other hand, are looking at ways they can take intellectual property and trade secrets, give it to their mate down the road so they can replicate it, sell it. Yes, they're making money out of it, but they're now also doing a lot of other damage to other people around that system. So when it comes to intellectual property and trade secrets, you probably don't think you have any. But as you walk up in or get promoted in defense, you'll gain access to other resources. They are intellectual property and trade secrets of defense themselves. You have access to not so much client and staff and business, but you have access to families. You have access to your oppos around you. You have access to other components. And if you think about it, if I hacked into your mobile device and I sent an email from your mobile device to your best mate saying, I need to borrow $50, can you dump it in this account? Would they do it? Well, it depends on who you are, but most of them will. So if you have access to money, they want it. If you have access to intellectual property, they want it. If they have access to client information or your friends and neighbors, they want that as well. But if you haven't got any of this, it's still not that big a deal for them because they can use your technology in a number of ways. Okay, they can use that to target someone else. They can use it as a Trojan horse to get something into a network. You're going to walk in. One of the biggest scares we've got with the new ships that are coming into the Australian Navy is most of them are managed by people walking in with laptops. Okay, and most of the operating systems are Windows 7, even as bad as Windows XP, which means that if I can compromise your laptop, you're going to walk in and compromise all of those devices that you are going to plug into. Not a good idea. But for technology, as a bad guy, that's great. And again, these are the things we're going to discuss later on as well. Now, some of the biggest problems with all of this is we've got a law enforcement problem as well. Not so much that they can't catch people, it's the fact that they work out who is doing the thing, but they can't do anything about it because they're in another country. Do you think someone in Russia is going to get handed over to the AFP because he hacked into something? It would have to be a really, really big hack, and it would have to be in the best interest of Russia before we actually had a chance to actually see something. The Russian police are not going to do anything because it didn't happen in there. They've got enough to do. They don't have to worry about anything else. So law enforcement has some really, really serious problems because with legal problems, we've got country problems, we've got nation states. All of these then become a huge problem. And fraud is just boundaryless. It doesn't matter where you are, and the internet encompasses the whole world. So law enforcement are always working out what can be happened. At a 50% of the hacks that are happening, they're outside the country. Okay, yeah, the other 50%, that's anyway. Look, every time a system gets hacked, there is also the capability of actually finding out what happened. If you've ever deleted a file on your computer, one of the things that people think is, okay, I've deleted that file, my operating system can no longer find it, that means it's gone from my hard drive. No, it doesn't work like that. What happens is you get to a file, you delete that file, but all it does is it removes the pointer that the operating system knows where that file is. It also removes the locking capability of that file. So what happens is you delete it and the system now goes, well, that's free space, I can overwrite it. Sometimes, depending on how much room you've got on your hard drive, overwriting that will never happen. So someone comes along, hacks into my computer, hacks into another computer, and they do a forensics on my computer, and they think they've deleted logs or capabilities or anything else that's on there. I can guarantee that they are still there. They are there, relatively easy to get, as long as you have the right piece. And because you have the right pieces of equipment to get, then that makes it a lot easier for people to actually track what you've done. Now, depending on how good your hacking skills are, depends on how well you hide your system. Okay, we actually get a chance to play around with some of this stuff. Now, we have a cyber range. I'm sitting in the physical range right now because it's the best place I can do it from. But we also have a virtual environment that we've now set up together as well, so you can use it. You cannot break it. And the same as what we have here, if something does happen, and now I'll leave the same command to you lot. If you break my system, I will buy you a beer, because I can guarantee you can't. So, challenge accepted. But when it comes to this type of thing, you cannot break it. Okay, there are 4 computers on the system. They are designed so we show you exactly what happens when you get targeted by a system. We also show you the benefits of what we're talking about as well, so patching and updating and modern technology and all that sort of stuff. As I said, you cannot break it, and that's significant in itself. We have expectations, and they are, let's have a bit of fun. Now, this is probably the only chance that you will get to be able to break computers and have no repercussions. You can't, if you break your own, you're going to run around in circles because you now have to use someone else's computer. If you break an office computer, then they're going to come around and clip you over the ear. This place, you can break it, you can have a bit of fun, you can work out how to break things, and that also gives you the opportunity to be able to do other things as well. So why are you listening to me? Okay, my name is Roger. I am an author. I speak a lot. I train people. I write a hell of a lot on the internet, so I blog a lot on lots of different websites. I also run a pen testing company, and we do it a bit differently. We have a blue team in Canberra. We have a red team in Perth. The red team in Perth and my blue team do not talk to each other about business at all. Literally, we do the pen test. We do a pen test on an environment. We use the blue team to secure the environment. So we install all the required systems and spiders and everything else that we need. We then tell them the name of the company that they have to pick on. And then from there, we then see if they can get in. That way we can actually improve both sides of the organization, but it also means we actually can see how attacks are happening. It's no use getting a pen test on an organization that has not gone through the major components of how to detect an attack and how to stop an attack from happening. Because yes, you may be able to get in, but we also need to know that what happened, we saw what happened. We actually gave them the data that they extracted for the simple fact that we knew it was no data at all. And we can then track what it does and who does it and all that sort of stuff. I'm a business owner. I do a lot of this stuff and I love it. I've been doing this since 2016. Okay, so normally I would now come along and go, introduce yourselves. We're not going to do that for the simple fact it's too bloody hard over Zoom to do. But I will tell you what we have learned. The second question of introducing yourself is, what do you know about computers? So what do you know about the internet? What do you know about applications? What things do you know about digital? Now, most of you are digital natives, okay? 99.9% of you are under 22. you have been brought up with computers since you're the age of 5. You've had access to devices all of your lives. You have made decisions, you play games, you are now using them extensively here, but you really don't understand how those systems are working, how they're connected, how they talk to each other, what information goes backwards and forwards, how the information is actually flowing between, for instance, the browser and a web page. And those are the things that we have to teach you so that you have a better in-depth understanding of how you can protect yourself. So today we're going to cover cybersecurity and cybercrime kill chain. We're going to have a look at what that kill chain involves. Yes, it's an interesting name for it, but all it is this is the flow or pattern of an attack, and this is what we need to interrupt as much as possible. We're going to have a look at what the internet is and how does it work. We're going to have a look at risk and risk management frameworks, only briefly, because we do go into a bit more depth on Lab 3, just to give you an idea, because your assignment has something to do with risk. How do you mitigate the identified risks we come up with? We show you what the targets are, the strategies are, and the last thing we talk about is the CVSS, and I'll talk about that later. Right. The kill chain. Okay, Lockheed Martin came up with this idea about 4 years ago, because we needed to look at a way of how an attack came about and how that attack was then managed when it came through. The problem is this is designed for IT and technical people, okay, which is not much use when I'm talking to people who have no idea what we're talking about. So it's not as technical as this one, which is the Advanced Persistent Threat Lifecycle. The Advanced Persistent Threat Lifecycle is even worse because it's lots and lots of moving parts. They're all doing certain things as well, and we need to make sure that that doesn't happen. Now, Advanced Persistent Threats is literally the capability for a bad guy to get a piece of software inside a network that is undiscovered for a number of years or months or weeks or days, okay? Advanced Persistent Threats, we've seen one in the Ostel shipping company in Western Australia that was there for 9 months. We also, in January this year, we heard about one that happened in PM&C, so Parliament, Prime Minister and Cabinet, okay, and that was in their network for 90 days, and they reckon that came from China. So these are the things that we have to worry about. The problem is, as I said, these are very, very complex systems, and when you're talking to people who have really no understanding of what is actually happening, they make no sense at all. So we've broken it down into this. There are 5 separate environments that we need to worry about: reconnaissance, initial infection, accessing and changing the strength, moving it around the network to find out what's going on, and then getting the data out. So reconnaissance, we're going to find out not only who's using a system, but what that system is, why it's been used. We're going to then send them something that will get me my initial infection. Now, if I haven't done the reconnaissance, it's just going to be a random attack. Yes, I can still get the initial infection, and yes, I can still do the rest of it. But if I do the reconnaissance, I have a bigger impact. It means that I'm going to work out what is the best financial situation that I can get out of any attack. The next one is, once I've got I've got a foothold, I'm now going to make it a lot harder for you to remove me. So I'm going to use different types of malware. I'm going to use other things. Once I've got a foothold on this system inside a network, I now can move around that network relatively easily. Now, as you can understand, what I'm talking about here, if I haven't got any tools in place on my network, this is invisible. Okay, if I haven't got something that's going to tell me that someone's tried to hack into another computer on the network, then they can hide in this place relatively easily, because they're not going to have anything that's going to tell anybody about it. And then once I've got everything that I want, or I'm going to start feeding information out of my system, out of this system to my system, then I'm going to extract the data as much as possible. So let's talk about how this all works. Reconnaissance. Now, everybody's probably heard about open source intelligence. It's the ability to extract information, or little pieces of information that, once put together or combined together, makes a bigger picture of our target. Now, we use open source intelligence to make sure that clients are safe, but the bad guys use it to actually come up with a targeting scenario that people are going to identify with. So social media, the dark web, if you've been unlucky enough to be hacked, network scanning, I'm going to find out what devices you're using, how you're using those devices. Can I target the Android devices that you've got? Can I use the information that's on the internet or on social media? All of these things become bits of information that I'm going to combine together to give a picture of my target avatar. And if I can find out what my target avatar, what makes him tick, I can then pull a little string and maybe you'll do something for me. So the next one is an initial infection. And the initial infection literally is I need to get a foothold on that device in some way. And I can get a foothold in a number of ways. Social engineering, I can send you an email that you click on a link and go to a web page, not a problem. I can send you an email that says download this application. I can have a pop-up that appears on your browser that says you've just lost connection to Facebook, put in your credentials, and it'll then pop up, disappear, only for you to realize that you just lost that information and you need to do something about it. I can deliver it on a USB drive. A USB drive is probably the most effective way we've seen. There was an experiment in Sydney last year done by Cisco. They got 100 white USB drives and they sprinkled them all over the business district in Sydney. Out of those 100 USB drives, every single one of them was picked up and plugged into a computer. Now, 53 of those were also plugged into corporate environments and 3 of them were plugged into servers. So to me, the easiest way for me to get initiate a hack is to actually get a USB drive, put all my software droppers and everything else on there, put a piece of information on there that my target may find interesting. While he's reading that, my software is doing weird and wonderful things as well. So these are the type of things that the bad guy has got. So I've now got a foothold on the system. Now, foothold is not much use to me. It just tells me that it connects my command and control to that system. It is an outbound connection. It's not an inbound connection. This device is talking to my system, not the other way around. And what happens is this will have a regular schedule and it will connect every half hour, okay? And in that half hour period, if there's nothing for it to do, it will just sit there and do nothing. But if there's something that I want it to do, I will then tell it that you need to download this, you need to run this, you need to install this, you need to do this. So that is the second part of gaining access to the system. And more importantly, I've now got a connection that may be very, very tenable, but it also might be very, very unstable. So I need to put a backdoor in there. I need to have a system that every time you restart your computer, it automatically connects to my software, my command and control. I don't have to worry about how I'm going to get into advanced persistent threat, something to worry about. Backdoor, I can download a keylogger, so every time you change your password, it's gonna show up on my system. All of that sort of stuff is very important to me as an attacker. I now have a compromised computer within a network. So I can now use that compromised computer and I can do a network scan, for instance. I can now look at all of the devices in the network, and if that's an organization that I'm trying to target anyway, that gives me all of that access. And now I'm going to look for some very, very specific types of environments. I'm going to look for things like accounting information, access to bank accounts. I'm going to look for social media access. All of these are then going to be data I can collect. And in a number of ways, once I've infected all of these places, I can then start moving all that information into one central location, ready for the next part, which is to get the data out. Okay, now I've got the data out, and now I have 2 things I can do. The first thing is I can leave everything in place, not worry about it. If it gets picked up, then we won't panic about it, because then we know it's going to be cleaned and we're not going to worry about it. The second thing I can do is I now have all that data. Now, the last thing my command and control system is going to do is we're going to download a piece of ransomware malware onto that system. It's going to bloody encrypt everything that it has the access to. We can actually push it out from my compromised system. And from my compromised system, I can now encrypt everything that's in there. Now, the good thing about doing that is while these people are running around in ever-decreasing circles, your security manager and everything else, your IT managers are running around, your management are running around, they don't even know that the information has been stolen. And now these, the attacker is going to make some extra money for the simple fact that, okay, to get your information back, it's going to cost you $10,000 for the key to decrypt all that information. You still don't know that that information has been stolen. Okay, so twofold. Great, I've now made instant money, but I've also got a backup as well. So how can we stop this from happening? How can we disrupt the kill chain? Well, first thing we can do is start securing our systems. Most of the malware that we use is targeting a vulnerability that we know about, or if you're really unlucky, a vulnerability that the operating system or the people who made the software don't know about. But if you've got up-to-date systems, you've removed 90% of those bad things already. When it comes to personal or corporate information, don't put it out there, okay? It's really, really easy to say, oh yeah, we're going on holiday to this place. Not thinking that the number of people who are actually reading that information or know how to find that information or have the capability of reading your mate's information because he hasn't secured your, his system, but you have, means that they're getting information about you. And on top of that, we've just seen some of the problems with Facebook itself is you can actually scrape the database of Facebook if you know how to do it. It was just done by a Chinese company about 6 weeks ago. So these are the type of things that we have to really, really worry about. Initial infection, once that I've got that foothold, I need some systems that are going to either stop it from happening or telling me that it's happening. So antivirus will pop up and go, we've got a piece of a virus here. Firewalls will stop it coming through because they know that they're looking for that pattern, not so much what that is. We've got intrusion detection, intrusion protection systems. So they're going to actually manage anything that happens on that device in such a way that we can actually make decisions about it. We have script management so that nobody can run a script on my computer without me knowing about it. And again, we're talking about patching systems, making sure they're up to date, making sure they're up to date as much as possible. We didn't catch the initial infection. So what do we need now to stop it going to the next stage, to stop them downloading stuff? Well, let's put in some two-factor authentication. Two-factor authentication is username, password, and something else. We have a couple of, in our legal side of our organization, we manage computers as well. And to get the management software or gain access to the management software, we need two-factor authentication to allow that to happen. We have a lot of whitelisting capability. So the whitelisting capability literally means that we know exactly what applications this organization uses, and they are the only applications that are allowed to be used. In addition to that, let's take all of the crap out of the system that shouldn't be there. What I mean by that, everybody's gone back down to JB Hi-Fi or Harvey Norman or Officeworks, and you've all bought a laptop or a computer of some sort. If you opened up your laptop, logged onto it and did all the right things, all of the applications, there's a number of applications on that computer that have been put there by the manufacturer. So if you've got a Lenovo, it'll have lots of Lenovo applications. Remove them. Okay, that is called system hardening, and it means that there's no opportunity for the bad guys to target that specific thing. Okay, I could send out a random email that targets a specific application that has been made by Lenovo, for instance. Okay, the chances of you having that on the system is, let's say, 10%. The chances of you clicking on the link that I sent you that activates that application is another 10%. Okay, so I've got a 1% chance that I'm going to infect a computer. That's still a bad thing to have. Okay, so now we've got access to a single computer and we've done some serious damage to that computer. Let's have a look around what's going on. Now, reduced administration accounts is rather critical. You will find we come across organizations where everybody has an admin account. And there's no way of tracking it, there's no reason for it, there's no need for it. So we literally come along and go, that person doesn't need it, that person, reduce it from 10 to 2, okay? Now, the thing about doing that, it means we can actually then consolidate some of our reporting stuff. Okay, the admin account, if it's used at 4 o'clock in the morning with username and password, and they gain access to the system, 4 o'clock in the morning, what the hell is someone doing up at 4 o'clock in the morning? So I would get alert because it's outside business hours from the monitoring system. If I have a username and that's been attempted on an admin account that's been attempted on a computer 5 times, I then get a warning. Okay, obviously that is someone phishing for the right password. Okay, best idea, check password, make sure it's complex, rechange it if necessary. Or I might have this computer have admin access, username, password, bang. This one accessed, same thing. This one accessed, same thing. And the space of 30 seconds. And the trouble is I know that this and this are in 2 different buildings. Okay, then I would also get a monitoring information out of it as well. So what I'm doing is now building up a picture of how my organization can get attacked and making sure that if that happens, then I am going to get a warning that something has happened. Most of this is achieved through what is called a SIEM or a SOAP, depends on how you look at it. A SIEM is a System Information Event Management System. Okay, everything on the network points back to that. It correlates all the information that it receives, and some of the information is it can receive 1 or 2 gig a day, so it's a fairly chunky type of system that you need to have in place. But it also uses that information to feed me back my monitoring and alerts that come out of the system. And then what do we do about getting the information out? So they've got all this. Okay, they've done all the right things. They've gained access and done everything that they need to do. They've now got a pile of data they're going to try and get out. Well, let's have a look at how they're going to get it out. So IDS and IPS, intrusion detection and intrusion protection systems. If they're in place, then there's a very good chance that they're not going to be able to extract the data, or we've got a better idea, let's give them some false data. That's the data they can extract. We can actually keep our secure data. Doing that is a thing called a honeypot. Okay, we can actually change the firewall rules. Now, firewalls are designed originally that anything on the internet coming in is stopped. Everything from the internal network going out is allowed out. Well, that's very well and good, but we talk about ports later on. If I know that only the required ports are allowed out, then those are the only ports I allow in my rules. So people can surf the internet, they can send email, maybe there's a requirement for a VPN to another client, okay? So those rules are in place to stop anything extra going out of the system. And the best thing you can do is apply encryption across the board. Now, encryption used to be a big problem because it was a really big overhead on both processors and RAM. It's no longer that big a problem. Okay, most of over the last 4 years, there has been a chip on all motherboards that have come out of Intel that does all of the encryption. Okay, so it's hardware encrypted at the motherboard level, which means that I can actually start locking down information. And if you use a thing called BitLocker, which is available through Microsoft, and I think Apple's got something similar, you can actually encrypt your hard drive so people can't read it unless they've got the username and password. Absolute pain for us, for the simple fact that if you don't have the password or we don't have the password and your hard drive breaks, then we cannot get your data back. So you have to make sure that you have things like backups and everything else in place. This is the 3rd video, Anatomy of an Attack. It does show you what happens. It shows you the impact of stock markets when a hack happens. It is very good in that respect. So let's talk about this internet thingy. The visible parts of the internet, what we see, let's talk about how it works and goes between the communications of the OSI model. Okay, so let's have a look at my pretty little iceberg. We all know icebergs work on the principle that 1/10 is above the water and the other 90% is under. Well, in our case, it's 9% that's above water. The digital world is the iceberg. The bits that we see above the surface are the pieces that Google and Bing and Yahoo want us to see. Okay, they are the systems that are in place that are involved in getting information and giving us information when we do a search. Most of the time, that 10% is literally the visible internet. That's the internet thing that we use rather significantly. The second part is a thing called the deep web. Now, the deep web is legal documents, financial records, raw data. Okay, Internet of Things has it produces a significant amount of information going through these systems. They've just developed an Internet of Things tracker for bushfires. Okay, the trouble is the amount of information it creates is significant. Okay, and that's good or bad, depends on how you look at it. Mainly because the battery doesn't last long because it's always doing things, but it's also checking humidity and temperatures and shade and you name it, it's doing all these wonderful things. And they have the capability of literally spreading them all over a forest, and they'll give you back information. Great stuff, but it goes into a system that only has one system that can read that information. Now, this is the problem with the deep web, is that to get information out of that, because it's not catalogued by the systems, then there is a very good chance that that information is well hidden. There is a company called Elastic that has an application that does some very good remediation of just basic data, and most people who are using it are getting some significant pieces of information out of it. The last one is a thing called the dark web. Dark web is about 1% of the internet, or of the digital world. It's where all the illegal stuff happens. It's where information is bought and sold. It's where drugs are bought and sold. It's where guns are bought and sold. To access the deep web, you need a piece of software called Tor. Once you've gained access to the deep web, everything that you know about the internet don't work there. There's no such thing as search engines. There's no such thing, well, there is, but they are not as easy to use as Google and Bing and Yahoo. In addition to that, there's also this flow-on effect. You're in a very, very bad place, so you have to be just as careful as the people who are down there. So let's have a look at what the basics are. We've got this wonderful digital environment. How do we connect to it? What do we do with it? How did it come about? The first thing let's talk about how computers actually started. In the late 80s, early 90s, we had things called mainframes. Those mainframes were a computer with a centrally located processor with databases and all that sort of stuff that was put together. And we had then peripherals all around it that did all the input and output to allow that central location to do all the work. Okay, great stuff. Individual terminals, terminal broke, system kept going. Terminal broke, you just got another terminal, or you moved to someone else's terminal, whatever, it wasn't a problem. If you want a printing done, it went through the system and came out as a printer. Great stuff. The problem is if that central location went pear-shaped, everybody stopped working. So as you can understand, that's a huge problem. But bring it forward to today, think about this. Office 365, okay? Central location controlled by Microsoft. It's not a single location, but it's a large location managed by Microsoft all over the world. Okay, so we now have a central location there, and we now have the terminals, which is your browser. Okay, your browser connects to Office 365. I can open up Office 365 no matter where I am, as long as I have a connection to the internet. So we've really gone full circle when it comes to start topology. The next one we came up with between 94 and 97 was a thing called the token ring. It was created by a company called, I've forgotten. But the token ring was literally, we could actually have lots and lots of computers joined together. Lots in those days was anything up to 10. Those computers talking to each other, they could get around and talk as much as they want. It didn't matter what they were. The information that literally went around the network as it was. It only went in one direction, didn't go in the other direction. For my computer to talk on a token ring network, it had to have the token. It held onto the token for under a couple of milliseconds, then it passed the token to the next computer and next computer and next computer all the way around, and then I got it back. Everybody could listen, but only one person could talk, which is great until you start looking at a couple of hundred computers, and that token was taking 2 or 3 seconds to go around the network. So information really slowed down to a level where it wasn't much use to anybody. The other problem with the token ring network is it's the ring. Break the connection between any computer and they all stopped communicating. Yet they could still function as computers, but they couldn't talk to anything else because they no longer had a system. So in 1996 through to 2008, we had what is called the buzz network. The buzz network literally is plug a computer into it. All of the computers are talking to each other. They have no central location of control or where information is being stored. If I wanted to write information from my computer to another computer, my computer would actually yell to that other computer. Okay, where are you? What are you doing? What's your IP address? What's your MAC address? I am now going to connect to you. I'm going to send you information. So all of these computers are yelling and screaming at each other, created lots and lots of noise on the network. The problem is, if you had 100 computers, that was great. But if you increased it to a couple of thousand, the noise became the problem. Because each one of those noise environments, you couldn't do anything. Because what would happen is you'd get collisions between the data distribution points. And because you were getting a collision, both of those computers would drop off the network and they would come back on at separate times. If there's a minimal number of computers, the collisions are very, very minimal. But when you start adding extra thousands of computers, these become a regular thing. The trouble is when they hit, dropped off and came back on a normal time, this one would hit another one and it would drop off and then it would come up and hit another one. So what was happening was the speed of transfer of data became a huge problem because it was now all of this broadcast information that was happening then became the problem itself. So we went, oh, this is not good. So between 2005 and today, we use what is called a mesh network. Now, a mesh network requires on very specific pieces of software. You ever wondered why you open up, you connect to the computer and you can type in www.news.com and it'll actually put the news.com up there. Okay, now every computer on the internet, and that includes computers that have that are inside a network that are communicating with the outside world. Every computer on the network has the capability of finding every other computer, as long as there is a system of finding that in place. Now, the difference is if it's behind a firewall, yeah, we probably won't be able to do that. But if we're sending information from my computer, open a browser, go to news.com, then that information is going to come back. What happens is my computer doesn't need that information. It literally asks the internet, okay, where is news.com? And it will get an address. And how do I get there? And it will get that information as well. So the information is now transferred between the two. What we see at this top level is open up a browser and go to a website, okay? But these systems are working in the background. We can combine all three, these systems into a mixed topology, and we do, okay? The mesh network is the internet, okay? It has function and capability that it allows 1 million or a couple of 100 million computers to talk to each other. The buzz network is still used, okay? This is where Wi-Fi sits, okay? If you connect to a Wi-Fi connection, my computer can see all of the connections that are connected to it. Yes, there is technology called isolation systems that allow me to plug into a Wi-Fi network and not see all the others, but 95% of the people don't use it. The other one is software as a service. We still have the star and spoke environment that then goes off and gets that information as well. Now, on a side note, there's another topology that came up in 2012, I think it was, and that was the one developed by Apple and Google. Now, what people don't realize about Google is this. Google has a platform. That platform allows you to plug into it as a search engine and get information out of that platform. Now, to populate that information, they have got things called spiders that go off to the internet, and they are looking for a thing called keywords. Now, our keywords, for instance, are business security. Okay, so they will come to my website, they'll look at it and go, well, he mentions business security 52 times on the whole 95 pages that are here. But that means he's only focused on that. We're going to put that into our database as business security. Great stuff, not a problem. So what happens is, someone comes along, opens their browser and types in business security. It looks at the information it's got in its database and goes, yes, I can find 2,500 or million responses to business security. Great stuff, not a problem. And then categorizes those as the best beneficial site that you're going to. So now Google is managing exactly what it's supposed to do, which is it gives you the response that you want because of the questions you're asking it. Now that's great, but you suddenly realize you still haven't got onto the internet yet. If you type in a URL into the browser, it goes directly there. If you type a search phrase into Google, you get the results, which are the results on Google. And when you click on the link that is one of the results, is when you go to the internet. So you literally bypass the internet until you actually come up with where you want to go and click on that link. Now, this came about because Google promised that you would get a result for your search within 1 second, and they've tried to adhere to that all the way through. And there's something like 22 billion websites out there at the moment, and if you multiply that by 10 or 15, that's how many web pages there are. So if you had to search all of those to find the information, then we would still be waiting for the first search. Whereas if you search on Google, which has business security, this URL, click here. Okay, makes it a lot easier for them. But we have this attitude that open up a browser, go to a website. Isn't that right? We all think that's how it works. Type in www.news.com and it goes to news.com. Great stuff, no problem, everybody happy. Well, what we see here is not really actually what's happening, okay? If you open up your browser and you type in news.com, okay, www.news.com, because you want to see the news. Great stuff, no problem. So the first thing my browser does is it goes, where the hell is news.com, which is DNS, okay? It then goes, okay, DNS is here. Okay, I'm going to go ask that machine for DNS. I'm going to get the IP address. I'm going to learn how to get there, and I'm going to deliver that information to it. We then work out, the browser works out that it's actually going to https://www.news.com. So now we know that there's encryption in place. So the next part, which is the presentation layer, actually looks at the encryption and works out how it's going to encrypt that data and make sure that that information is encrypted. Session component, the session layer, layer 5, is all about separating information out of the system so you don't get contamination. So what that means is I've got 5 browsers open on my browser. Each one of those browsers is managed by the session manager to make sure that information from tab 1 doesn't go into tab 3. The next one is what information are we going to move around and how are we going to move it? This is the protocols, okay? TCP, UDP, TLS, anything along those lines. The next layer is the network and the address. This is my address. I have to go here. How am I going to get there? And off it goes. I have a physical address on my system itself called a MAC address, and that's used later on. And then we have a physical address, literally, that allows us, a physical system that allows us to transfer all of this information into a cable and send it across the internet. Now, although we're not using a cable because we're on Wi-Fi, we class Wi-Fi as a cable as well, okay, just for this exercise. So it gets across to the server that has the information that I'm after, and it goes, well, I've got the information, so I don't have to worry about the physical layer. I don't worry about the data link layer because I have a MAC address as well, and those 2 addresses don't have to talk to each other. I have a network address, so I know exactly where the information is coming from and going to, and how it's going to get there through the internet. I have a transport layer, which is going to look at TCP or UDP. Have I got a connection in place, or am I just going to broadcast all that information? I don't have to worry about the session because that's that end's problem. I'm going to worry about the presentation layer for the simple fact that I've now got to encrypt all the data using the keys, and that key transfer has already gone through because of the DNS and the www HTTPS component. And I'm now going to send all of the information across the network from here. So as you can understand, open up a browser and go to a website doesn't really happen. All of this stuff is happening literally in a split second. All of this stuff is being added and removed and changed and initialized before you even finish typing it. Okay, it knows that you're going to .com before you actually press the button. It's probably worked out half of this stuff already. The problem with this is each one of these layers is a location where I can steal information, compromise systems, or cause major problems for the users. And that includes things like exploits, spoofing, man-in-the-middle attacks, DDoS attacks, hijacking, anything along those lines. Yes, we have ways of stopping it from happening, as in you can see on the right-hand side, but there is very, very minimal. If you don't know that this can happen, then you are very, very liable to have it happen to you. And those are the things that we've got to think about as well. So we've got protocols. Now the protocols are designed to actually send and receive information from both ends. Once you've got to have a connection in place. Now the first thing that the protocols are going to do is actually have a connection. Now the first type of protocol we use is connection based, which is TCP, Transmission Control Protocol. Okay, it's reliable, mainly because of the way it's been set up. The first thing that happens once I've gone through all that crap with the OSI is my system tells your system that I want information from it. So it literally sends a piece of information, and this process is called a handshake. That handshake is, I want to get information off you. Yes, I'm ready to actually send it to you. Okay, let's communicate. Okay, there's then a secondary handshake, which is part of the encryption process, but we won't go into that. TCP then gets a connection between the two. Now it only allows, the information can only flow between the two devices over that connection. There's also now a thing called a window in place and flow control. So my system is going to ask information from that end, and it's going to go, okay, send me 1, 2, 3, 4, 5, or start sending me information. And the website at the other end is going to go 1, 2, 3, 4, 5, 6, 7, 8. That's the end of my window. I'm going to send that through. Gets to the other end, my PC looks at it, and my browser looks at it and goes, yep, got that, no problem, send the next lot. So now we have segments in place, and we have packets flowing backwards and forwards. But we're also checking to make sure that we're not getting data that shouldn't be there. So if I suddenly get the server suddenly turns around and goes, I'm going to send 1, 3, 5, 7, 2, 4, 6, 8. And my system goes, no, you're not. I'm not going to allow you to do that. I want it in this sequence and in this order, otherwise I am not going to accept it. Sends a, do it right, back to it, we send the right information. So we now have a very, very reliable situation. And if you think about it, it's like me talking to a mate over a beer in a pub. Okay, me and him are sitting opposite each other. I have my beer, he has his beer. We've had a shake of the hand to make sure that we are, we know each other. We're now communicating face to face. And that's what TCP does. It's a face-to-face communication over a single connection. There's no chance that I'm not going to hear what he says, or he's going to mumble something. I'm going to say, what the hell was that? He might say something and his face might be different, so I'm going to check that. All of this is because I have that face-to-face connection. The second protocol we see a lot of is UDP, user-defined protocol. Now this is a bit different. It is unreliable. You're actually using it when you're connected to Zoom. Okay, there's a TCP connection between your device, the server, and my device and my server. Okay, so the information is literally going from your computers to that server, and I am now integrated into that thing. But from a technology side of it, the information is going backwards and forwards. If I have a shocking connection, which is one of the reasons why I'm here and not at home, because my connection is really, really bad, that information pops and carries on and goes all fuzzy and drops things and causes major problems going forward. So as you can understand, when it comes to making sure that the information is there, yeah, TCP is in place. It's created the channel. Now we're using UDP to send the information back again. And if you wanted to talk, it would go over the UDP channel, nothing else. So that's why if you hear people talking in the background, they're popping and carrying on. Okay, and that's because it's UDP. Mainly because UDP doesn't care, okay? This TCP is me talking to a mate in the pub. UDP is the sergeant major standing in the middle of the playground going, right, you lot, fall in, okay? He's not talking to anybody in particular, he's talking to everybody. And because he's talking to everybody, it's up to you to actually define what he has said and then do something about it, okay? If you think about it, you're then going to watch everybody else, and everybody else is going to start milling around and walking towards wherever you need to go. But because it's a broadcast, if everybody didn't get it, the sergeant major is going to turn around and go, right, you deaf pricks, everybody fall in. Okay, so he's going to define the broadcast a lot better. And that's, again, what UDP does. So we haven't got There's no connection. Everybody can see it. There is no windowing, no retransmission. If there is a retransmission, it's a retransmission of the whole lot. Okay, it's not worried about when, or there's no retransmission at all. Okay, which is the other thing about Zoom. It doesn't go back and go, you missed all this bits. Okay, because it will pop in and carry on. It just goes, I'm going to start here again. Okay, and that's the difference. So I now have TCP and I have UDP. And the next thing I have to worry about is how the hell do I get the information to go backwards and forwards? Now, UDP and TCP have things called ports. Now, there are 65,535 ports per IP address on the internet. As you can understand, that's a huge number. So ports are like having channels. So I have Foxtel at home, and anybody who else that has Foxtel will understand this. If I press 102 on my control, I will get ABC News. If I press 529 on my control, I will get the racing, horse racing. If I press 601, I will get Sky News. If I press 608, I will get the History Channel. So each one of those ports, or each one of those channels, is related to a number that I punch into my control. But if I pressed 102 and I got the racing channel, I'd be a bit confused. Okay, and that's the significance of how ports work. Because I can now define that if I go to anywhere and you have an account on Foxtel and I'm watching your TV and I want to watch Foxtel, I can press 102 and get ABC News. Doesn't matter where I am, doesn't matter what I'm doing, as long as I have that Foxtel connection, I can do what that requires me to do. So when it comes to TCP and UDP, we also have what is called default ports. Okay, so I open up my browser and I go to a web page. So I've typed in www.news.com. Okay, my connection normally would be port 80. Okay, I send the information across on port 80. Today's world, we now use 443, so everything is encrypted, everything is hidden. Nobody can get at that information, sort of. I'll come back to that in a minute. So 80 and 443. I want to run up a website, a web page on my internal network. It's going to be on port 80 and port 443 if I wanted it encrypted. If I wanted to build a new web page on the internet, it's going to be built on port 80 or port 443, depending on what I need. So if anything comes along and I want to get to a web page, I open my browser and I type in the URL and off it goes, because it goes to port 80 or port 443. About 5 years ago, well, up to about 5 years, no, it wasn't actually, it was about 8 years ago. We used to have a thing called security by obscurity. So what would happen is, Joe Blow would come along, he'd build a web page, and instead of being on port 80, he'd put it on port 79. So my browser can't see it unless I tell my browser to look for port 79, which is relatively easy to do. But I have to know that that's there, so it's obscured. About 8 years ago, we got access to a tool called Nmap. And Nmap is a piece of software that maps network connections. Okay, so I pointed at that IP address where that system is hidden, and instead of coming up with 80 and HTTP, it would come up and show 79 and HTTP, because it would have tested to make sure that that is in place. It would then show me that that port is open. So I no longer am obscured, I'm no longer hidden, I no longer have anything in place. Same with SMTP. If I want to send an email from my system, okay, I have to send it on the same port that everybody else is listening to. So everybody is listening to port 25, so it's no use me sending it in something else if there's no port 25 open. So if I change my port to 525, for instance, and send out an email, then it's not going to get picked up by anybody. My system will go, no, there's nobody out there. If they change their ports to 525, yeah, not a problem. But nobody's going to do that because port 25 is SMTP. If you do a search on the internet, on Google, and go TCP ports list of, it will give you a couple of thousand ports and what applications are behind them. And the good thing about that for a bad guy like us is it tells me exactly what is behind a port, an open port. So I can actually scan the system and go, okay, port 443 is open. I have a Linux server that's running Apache. okay? I've now got some very, very specific information about my target machine. But we need hardware to get all this across the internet, and that hardware comes in a number of ways. The first thing we had, remember going back to all that traffic on the buzz network, we had hubs. Lots and lots of noise. We still use hubs in the Wi-Fi area, but they created so much noise that they weren't much use to us. The problem is we then, in 2008, we came up with a new system called a switch. And this is where literally the birth of the internet came from. Because I can put a switch on there, the switches are managed, there's no broadcast of information, it makes it a lot easier. Switches work on the principle like this. We put a switch into a network, I have a computer here. I turn on my computer. The first thing my computer does is it sends my physical address of this device to the switch. It gets that information on the switch and goes, all right, got that. I know that port 1 is now that address. Okay, as it loads up the operating system, it now gets an IP address. And once it's got the IP address, it associates the IP address with the MAC address, and that is then sent through to the system as well. So there's 3 pieces of information about this computer. Computer name, MAC address, or the physical address, and the IP address. And that goes into a table on the switch. The moment this thing is finished booting up, it then asks the switch to send it a list of everybody else on the network. So you then have a list of all the 35 computers in the network, and it says name, MAC address, IP address. Great, not a problem. Which means that my computer, if it wants to talk to that computer over there, knows exactly where it is, knows exactly what name it is, knows exactly what IP address it is, and knows exactly what physical address is. So it doesn't have to broadcast any information at all. And if I turn on a new computer, it will get a new list come down from the switch. So each component now knows exactly where everything else is. If I've got a printer on there, I know exactly where the printer is. The printer has a MAC address as well. Every device that has a network-aware device has a MAC address. And that is very, very noticeable when it comes to all of the things that we're talking about. Once I've done that, to get that broadcast capability, I actually have to physically change a switch on the switch, as in physical switch, off on, okay? That then turns it into a thing called a promiscuous mode, which then collects all the information about what's going over the switch. So I need to make sure that that is secure as well. So I can make sure that the switch is in the rack, it's hidden away, it's doing all the right things, or the switch that makes it all do all the right things is not accessible from the outside world. So all of the information is now going from my device through the switch, at the switch, to that other device that I'm targeting. But think about all these computers here. They're now talking to each other, they're all quite happy. Think about them as we're now having a street party. Okay, we're having a street party, everybody's having a beer, we're having sausage sizzles, everybody, the kids are running around, all that type of thing. We just run out of beer, okay? And if we just run out of beer, we need to go and get some more. So this is my network. I now have to go out of my network to go onto the internet to get information. To do that, I need a control system, which is what is called a router. That router actually manages everything coming in from the outside world is stopped, and everything from my inside and my cul-de-sac can get out if it needs to. So I can go out, but I need to pass to get back in again, okay? And that's the significant difference. And that pass might be just because I'm driving a car with a sticker on it. Easy. But the bad guys, being bad guys, found ways to create major problems. So if you go to Harvey Norman or JB Hi-Fi or Officeworks and you buy yourself a router for your NBN, okay, it comes with what is called a legacy firewall. Now, a legacy firewall looks at layer 2, layer 3, layer 4 of the OSI model. Layer 2, MAC address. Layer 3, network address. Layer 4, protocol. Okay, so I can block a protocol from going out or coming in. I can block an IP address from going out or going in. And I can definitely block a MAC address because that's not routable anyway. So I've now got a connection that allows me to secure the connection, but also causes other problems as well. Because the bad guys, being clever, went, okay, we know you're using TCP and this is the IP address. I'm going to make myself look like something else. I'm going to come back into your network. That's called spoofing, huge problem. So we had to come up with solutions apart from that. So we now have what is called the next generation or second generation firewall. The ones you can buy from Harvey Norman and all those are not usually second generation firewalls. They don't look at layer 7. Now, layer 7 literally means my browser opens up a browser and it goes to my web page that I'm actually looking at. It looks at that and goes, okay, at the layer 7 level, we are looking at HTML traffic. Okay, HTML is what web pages are designed in. It takes information out of the system, sends it across to me, and my system rebuilds it again. Great stuff. And anything that is not in the right place gets caught and literally gets dropped. So HTML and some scripting comes through, but some scripting that is we know is bad, we can extract it, put it into the bin, and we don't have to worry about it. Great stuff. The second part of that is, okay, instead of HTML at port 80, we're now using port 443. And the other thing about 443 is everything in there is encrypted. And that in itself is a problem. But because it's encrypted, anything that's unencrypted or comes through as plain text is also automatically dropped by the second generation firewall. How do we stop other things from happening? We're sitting inside a secure environment. Someone's got access to the internet. We're now going to encrypt data and we're going to send it out. And that data is restricted or secret or top secret. We're now in a situation where we have to think these things through. When it comes to the bad guys, no, on second thoughts. When it comes to the good guys, we need ways of tracking this. Places like AFP, Defence, some of the government, high-end government departments like ASIO and ASIC and all those things have specific pieces of software that actually download the HTTPS stream, unencrypt it through their devices, checks it to make sure there's no data in there that shouldn't be in there, re-encrypts it, and then puts it out on the internet. To do that, they actually embed a certificate in the browser that allows them to do that. So the certificate encrypts the information going this way, and the website information is then encrypted on the other end. Okay, so we can see exactly what's going on. Because we can do that, we can make sure that information is not going through the system that shouldn't be going through. And it makes it a lot easier to manage because we can offload it. It's an automated system. It's looking for keywords. It's looking for information about certain things. Okay, so it has that capability. But as you can understand, it's a problem with security anyway, because we now have to offload the security and the encryption to do that. So let's talk about wireless. Now, one of the things we understand is wireless is freaking everywhere. It came about in 1999, developed by CSIRO. Very clever bunch of people came up with a way for that computer to talk to that computer. The original and the first cards that we're using wireless were about the size of a keyboard. They were huge, but we've now got them down to the size of your fingernail on as a chip on most motherboards. Allows us to do so much more. We can go anywhere, everything's mobile. We're all happy and quite happy sitting in pubs and everything else when COVID goes away. But there is one downside, and that is a thing called free Wi-Fi. Now, free Wi-Fi is available on buses, rail stations, McDonald's, Starbucks, you name it, it's out there. Anywhere that you go where you want to use free Wi-Fi, and it comes up with the all care, no responsibility URL that says, click here, put in your email address, click here to accept conditions and connect. Don't do it, okay? Now, I can replicate that. I can put it on my system. I can walk into McDonald's. I can put it above McDonald's. So everybody who's now connecting to it is now going to connect to my device. And I now capture everything that's going through it. With the new changes in technology we're now seeing with HTTPS stuff, I can actually get a certificate into your browser that will encrypt data that I can read. So again, be very aware of what Wi-Fi can actually do to you. So when it comes to 1999 through to 2001, Wi-Fi literally exploded. Everybody wanted it. Everybody had capabilities. Everybody was really interested in it. 2001, we found out we had a major problem. All the data could be read and the bad guys were actually reading it. So we needed to do something else. So we came up with some encryption capabilities. First try, wired equivalent privacy. 8 bits of encryption, hexadecimal encryption codes, pain in the ass to set up, but today's computers, they can break WEP in under 10 minutes. So not a good thing to use in today's world. So we came up with, in 2005, we came up with a new one called WPA. Now, WPA, Wi-Fi Protected Access, is a bit more robust. 16 bits of encryption, anything on a keyboard could be used. So I'll rephrase that. Letters and numbers could be used, nothing else, no capitals, and made for an encryption a lot more robust and a lot more stable. It wasn't actually broken, but it has been manipulated. So we came up in 2008, we came up with a new one called WPA2. Now, WPA2 is a thing called pre-shared key. Pre-shared key is we have a passphrase. Passphrase can be anything on a keyboard now. That key passphrase can be put into a system. You now connect. You have access to the internet. Great stuff. Enterprise, on the other hand, is a bit different. Enterprise uses a username and password. You need a bit of infrastructure behind it, and that username and password then allows you to granularly control the people who are connecting to it. You can literally say that if this account comes up onto my system, it's only allowed to surf the internet between 1 o'clock in the morning and 2 o'clock in the morning. Okay, I can actually granularly control that if I need to. Pre-shared key is vulnerable to a brute force attack, especially if it's a weak password. So if someone's used ABC123, ABC123, that is a weak password. It's also vulnerable to attacks where I can replicate a access point. You're going to connect to it using your credentials for that access point. I can capture that information. In 2018, we came up with a new one called WPA3. A lot more secure, 192 bits of encryption. But this is a bit unique because the pre-shared key is actually set up. And when you use that pre-shared key, it uses information from your device to come up with a totally new encryption capability, which means that every one of the encryption connections are now individually encrypted. They're not encrypted with the same piece of information. So it's harder to intercept the handshake process. It's also very easy to set up 2 tick boxes and fill in the password and bang, you're off and running. There's also a 5th one called WPS. And if you ever come across it, turn it off. Do not use it because it's a load of crap. It uses 2 sets of 4 numbers to actually get an encrypted tunnel. These computers here can break 4-digit numbers instantaneously. So it's pretty bad. And also, if you leave it open, it allows anybody to actually use the WPS component to compromise this device in the background anyway. And that's also something bad. Let's talk about risk. We have risk components, risk management. Anything to do with risk is, let's find out what the risks are. And when you're doing a risk management look, you are looking at all of the risks. Okay, we're not just talking about these are the ones that are going to cause problems. If you look at all of the risks, you don't miss anything. And also you may have a different idea to what a risk might be when it's impacted from a different direction. So if you're actually qualifying all of the risks, it makes it a lot easier to manage. The best way to mitigate risks are people, process, and technology. Doesn't matter how you put those together, whether it can be one single thing or it can be all 3 combined. This is a simple risk management strategy. This is a different one, but that actually allows you to do a lot more. It also uses some of the information that's proprietary from ACELA's 8 Consulting, but it shows you what it can do. And this is the one that most of us are using. This is a thing called NIST. Now, NIST is a framework that allows you to actually look at the risks and come up with a way of implementing change to those risks. When it comes to how you manage it, the whole thing is based on a baseline. What that baseline, or how you generate that baseline, is 98 questions. Each one of those questions has a 1 to 4 answer. So 0 means you've done absolutely nothing in that question. Number 4, the top of the score is you've done everything, you've implemented it, it's managed, it's monitored, it's best practices, you name it, it's in there. So you come from 0 to 4. What happens is you answer all 98 questions, you then add them all up and divide by 98. That gives you a number between 0 and 4. Most organizations, when you first start with this, will be in the range of about 1. Okay, it's not a test. It's just a starting point. This point is where you start from. Now, the good thing about NIST is each one of those 98 questions that you've been asking yourself has a process or procedure or technology behind it that now increases it from 0 to whatever you want it to be. So you're now in a situation where you can individually take each component and tighten up the security around your organization. Now, in addition to that, you can actually use that as a monitoring and communication tool. Okay, you have a supply chain and you're in a supply chain and you're supply chain management. Okay, the people above you will come to you and say, what's your NIST rating? You can turn around and go, no, 3.1. Okay, and they will go, okay, we can spare data with you. Okay, we can actually mix data together. It's not a big deal. We're going to treat the same data the same way you are, and everybody's happy. The person underneath you might come to you and say, well, our NIST rating is 1. Okay, so we're going to be very careful about what information we're going to share with you, unless you can bring your NIST rating up to the 3s that everybody else is on. Okay, so it gives you that granular control over how you manage data. How do we get rid of it? Well, how do we mitigate risks? Well, let's talk about prevention. So how do we stop something from happening? We put a whitelist in place. So you get a piece of malware on the system and it can't run because it's not allowed to. We've patched everything up to date, so there's no vulnerabilities and there's minimal vulnerabilities. Yes, there are still 0 days there, but we can manage that. We make sure scripts don't work, going back to whitelisting, and because there are macros inside, say, Office, a Word document, we make sure that they are signed or they're turned off. System hardening, we removed all that crap that Lenovo put on my system, and I'm using Lenovo for a specific reason, is because it's Chinese and it's a problem with Chinese systems. Education, teach everybody, increase awareness. You will be told when you get out of ADFA that you only have to do a refresher course once every 12 months. My recommendations is do more regularly, or use technology. Throw an antivirus at it, throw a firewall at it, throw intrusion detection, protection at it. All of these things stop something from happening. How do we control or limit it? So something's got into our system, how do we stop it from moving around? Okay, yes, we can't stop it from getting in, but we can stop it from moving around. So admin privileges, only have 2 or 3 admins on your on the environment you're working in. Multi-factor authentication, username, password, and something else. You've got a dongle for Dreams. There's a thing called Google Authenticator you put on your phone. There's an SMS to your phone. Okay, it's something outside, or you can use biometrics. If you're using biometrics, it makes it a lot more difficult for people to get in there. Passwords, passphrases, how do you manage those? Everything on the internet needs to have a unique password. Now, there are 3 criteria for passwords, okay? They have to be unique. That means every site and service that you have access to on the digital world needs to have its own password. The second one is they have to be complex. They have to be anything on the keyboard. And the third part of it is they have to be more than 12 characters. Now, I've been teaching this, the lab since 2016, and in 2016, we were teaching that they had to be over 8. That's how much technology and the capability of the bad guys have changed. So anything over 12. So as you can understand, that's pretty difficult to manage. So get yourself a password manager, because they are really good. When it comes to data loss, how do we stop it from happening? Use encryption as much as possible. How do we detect something happening? Well, endpoint protection, things like antivirus. We're looking at firewalls, incident responses, SOAPs and SIEMs. These are make a central location that you can put on a board and show everything that's happening. And one of the most important things is we may be in a situation where we can't stop something from happening. If that happens, you better have a recovery component in place. Now, we have a rule. It's called the 3-2-1 rule. Okay, and it doesn't matter whether it applies to you, defense, organizations where you see, it doesn't matter. 3 copies of all information in 2 different locations, and one of them has to be off-site. Now, the reason why we're saying that is 3 different copies of the information is literally copying it onto a hard drive and then having an off-site backup. 2 different locations, on-site and off-site, and if one of them is off-site, make sure it's secured, encrypted, and really, really well protected. But the good thing about having an off-site backup, there's systems out there that run simple ways of getting on there. Literally, a username and password that creates the tunnel that puts the information in. It needs to be encrypted, which is part of the encryption key as well. Once it's created that system, it uploads everything that's changed in the last whatever time you've set it up for, 24 hours, 48 hours, 7 days. Once it gets to the end of that information, it severs the connection. There is no way that an infection on your computer is going to infect that. A USB drive plugged into your computer, that is a problem. Mainly because if it's plugged in, it's part of the environment that gets hacked. So malware causes a problem. When it comes to attacks, how do we look at them? The thing we've got to worry about is a local attack. I have access to your keyboard and mouse. If I have access to your keyboard and mouse and you haven't locked your computer, I have access to your information. Bad move, don't do it. You are in defense. And if you get up and walk away from your computer without locking your computer, someone will kick your bum. Okay, so just keep it in mind. A remote connection, this computer talking to a computer on the other side of the planet. Okay, now, before I go any further, there are two things I need as a hacker. If I want to hack into another computer, I have to have these two things. The first one I have is what is called a shell. Now, a shell is an environment that I can type on my computer and have it actioned on the other end on that computer. So if I type in open calculator, the calculator will open on the other end. If I type in open calculator here and it opens up this calculator, it's not a shell, okay? So I need a shell. The second thing I need is authority. Now that authority can be you as a user, it can be a system user. So one of the subsystems are using its own application or username and password, or it can be the administrator or the root user. This doesn't matter. If I have a user of some sort, I can send and receive information. That's all I want to do. If I have a shell and a user, that's when I've got a problem. Now, if I am just a basic user, then I now have to escalate myself from a basic user or a daemon or the system user and make myself the God account on the system. To do that is really, really, really difficult. Okay, it's not going to be done by an automated system. It is a complex process. It takes a while to do. So it's going to be a visible thing that has to be done, or it can be seen. But to get to access to the system properly, I am going to need to do that. Okay, so I need to be the root admin or the administrator. So I have a shell, I can do all the stuff that I need to, escalate myself from here, but to do that, really, really difficult. So when it comes to a remote compromise or a remote attack, this computer has to be able to talk to that computer, send it commands, and have the authority to run those commands. Zero-day exploits. Anybody who's a zero-day exploit engineer can make a lot of money. It's a vulnerability that's been discovered that hasn't been identified by the owners of the software, and that is something that they need to fix as well. Most 0 days you can sell on the dark web for a rather large amount of money, or you can send it to Microsoft, for instance, if they've got a problem. And as long as you have a documented thing that shows how it hacks, they will actually pay you money. We've done that twice so far. One of my guys is very, very clever at this stuff, and he scares the crap out of me. Social engineering, two components: manipulation, getting you to do something silly, whether that is plugging a USB drive into your computer, and the other part is the technology that comes with that USB, or opening up an email, or doing whatever needs to be done. Once I've compromised the computer, then that gives me access to that system. The targets that we've got are numerous. They really are. Vulnerable systems include Internet of Things. They really are out there. Baby monitors, doorbells, fridges, TVs, washing machines, vacuum cleaners. To me, why the hell does my vacuum cleaner need to connect to the internet? Okay, what am I going to do? So when it comes to this, just because something can connect to the internet doesn't mean that it should. And it's one of the biggest problems we've got, because everybody thinks it's really important that the system connects to the internet. Unless you're actually going to put some smarts behind it and security behind it, don't connect it to the internet. And even if you buy something, okay, that has the internet capability, unless you're actually going to use that capability, don't connect it to your network. Okay, and that's also something that you've got to remember. But hardware, there was a huge problem in 2018 where they found a physical vulnerability on the Intel and AMD chipsets. That caused major problems. Spectre and Meltdown were documented features of how they got in there, and it bypasses the operating system. Operating systems, yes, even Apple has malware and vulnerabilities. Applications, most of the large applications, things like Office and Adobe and all those sort of things, as in Adobe Connect and all those high-end systems. They are usually tied together. You open up Photoshop, for instance, it will actually make sure that it's the newest version or capable. It'll download it if it's not. Targeted attacks against things like Adobe Flash, Java, printer software, all of that sort of stuff is relatively easily done. So make sure it's up to date. So, and finally, the thing that we need to look at is a thing called Vulnerability Ranking Scoring System, so CVSS. Now, what this does is it's a standard where we can plug in information and we'll get a response between 0 and 10. Anything between 7 and 10 is something that I can get my shell and my user, okay? So those are anything over 7 we need to worry about. Anything under 7, maybe I'll get a shell, maybe I'll get a user, but I won't be able to do anything else unless I'm very clever and I can tie things together. So how do I get a score? The first thing I've got to look at is how is it going to get into the network? Is it going to be a Trojan that allows it to run around the network and disguise to something else? Is it going to be delivered as a virus? Is it going to be a worm? Anything along those lines is really important about working out how it's going to move around. How technical do I have to be to get it actually to work? Okay, can I download it off the internet, put it on a USB drive and give it to someone else, and all they have to do is plug it in and it works? Complexity is non-existent, okay? But if I have to hack into something, you've got to open up an application to get it to do what I need it to do, and while that application is open, I've got to send it other commands. That is a complex hack, and that is very hard to do. The third one is authentication. Can it action itself at this level as a user, or does it have to be administrator? And if it has to be administrator, how do I get it to that level? So those three are the really important ones. The other three impact how the CIA triad works. And CIA is confidentiality, integrity, and availability. We're talking about data and how we access the data. So confidentiality, who can gain access to the information and what can they do with it? So can they copy it? Can they delete it? Can they do whatever they like? Integrity, can they change it? Okay, the integrity of the information, and if you've got an integrity system, then are we tracking changes to it as well? And the last one is availability. How long can we last without having access to email, for instance? Okay, because the email server's been hacked or compromised or everything else. Once you put all this together, you'll get a number between 0 and 10. Anything over 5 is a huge problem. And I don't think we do that, which is a bummer. There's a couple of ways of finding out what the vulnerabilities are, and the vulnerabilities actually are displayed and really easy to pick up. There's also what happens if something does happen. Okay, what are the impact on the system when it does? We can have, previous to Triton, loss of life and damage to infrastructure wasn't actually on the scorecard. Now it is. Okay, we have now seen that it is easy enough to cause problems that could cause loss of life. We haven't seen it yet, but I think it's going to come in the next 12, 18 months. Economic, stock prices, revenues. Think about 9/11 and the prices of the airplanes. Okay, they literally went out the window. Psychological, is it going to cause depression? Is it going to embarrass people? Reputation is something that is very, very intangible, but you ruin your reputation, you will lose key staff. Relationship will be damages. Supply chains will have major problems. Key services are social, internal morale, all that sort of stuff. So we've talked about the kill chain. We've had a look at the internet, and literally hopefully you now understand that between this one and this one is no longer just a straight line. It's got lots of crap underneath it. Risk and risk management frameworks. We've had a look at mitigating and identifying the risks. We've actually looked at target, we've looked at strategies, and we've had a quick look at the CVSS. Right, what I want to do is give you a quick rundown on, I can find my glasses, on what we're talking about when we're talking about the virtual environment. This is, come here, that one, there. Okay, so to get access the virtual environment, this is what you need to do. You need to go to this URL, Learn on demand. You should have got an email. The people, the only people who have access are the user that has been nominated per group. But I don't think they're going to be very stringent about the fact that everybody can have access to that system if they need it. Just either get the username and password that the guy creates and off you go. So you get to this page and you hit the sign in button. Okay, if you haven't already been there, hit the forgot your password, put in your email address, and they will send you the email, and then off you will go. As you can see, I use LastPass as my password manager, and I sign in here. I'm going to go to Find Courses. I'm going to search for my course, and me being part of the area, I've got lots of courses on my system. But if I go to the bottom, where are you? And this is the one you're looking for. Zint2100 Intro to Cyber, Semester 2, 2020. And then after that, go here. I don't know why we have to do this so many times, but that's how it works. Okay, so you hit the launch button and a new window pops up, and this is how this all works. Okay, now you have 2 hours per session, but if you shut it down and come back to it an hour later, it stops the clock when you shut it down. Now, as you can see, it's starting to load up the systems. I am going to make that smaller because it makes a lot more sense to me. These are the instructions, and I'll get that out of the way as well. Okay, and as you can see at the bottom here, we have authentication, guide to the lab, so you get information about the labs themselves, how the controls work, all of that information is readily there, and then we get onto the labs themselves. Now, the resources you've got are 4 computers. We have our Kali machine, which is a penetration testing tool. We have Windows 10 1507, which is this one, and you can see that it's already started and it'll start most of the time. The 1507 is the first build of 2015, so it's about 5 years old. It was very, very clunky, and that's one of the reasons why we're using it. Windows 10 2004 is July's update that came through, and that is pretty secure. It also has updated operating systems, has updated applications, so just to show you how things work. And the last one is a thing called a web server, and all that is to do is so we had a website that you could connect to and show you how the problems actually arise. If you go through the instructions, I'll go back there, go here again. Okay, the instructions literally are next lab, lab 1, log onto the Windows 10 machine, 1507 machine, identify what version of the computer it is. So literally, this is what you need to do, and then write it down on the script that you have. As I said, it's up to you how you want to manage it as a group. The group information then allows you to do whatever you need to do. All right, so I will talk to you next week, and we will then continue with lab 2. So thanks, guys. Much appreciate your time, and I will see you next week.